Okay, now I want to show you something in the schematic editor. As you see, the page of a schematic or the sheet of the schematic is kind of a grid, and this grid determines the steps of your movement when you're moving your components. So by pressing G you can change this grid. If it's one, if I press another G, it becomes very small, and another one makes it like half the step. So, but you can actually change this grid if you need to. And if I come to properties, actually I need to first press O and then document parameters. In the parameters tab, in the general tab, sorry, you have visible grid and snap grid. Visible grid is the grid that you see here. So if I change it to 2.55, it becomes smaller. If I change it to 2.7, then it becomes even smaller. If I change it to 10, it becomes quite big. It doesn't matter, it depends on your schematic. It's standard 2.45. And this is actually the movement steps. So if I want to make it equal to the snap grid, I just press Control C here and Control V, and we have the same snap grid. And you can check, and you can also check it. For example, now you see it moves exactly in this way. But if I come in the properties again and make this half this, 1.27, then you see that the movement steps become half of it. So this is another thing. You can also change this color by here, I believe, and it's sheet border, and I think we can also change the snap color, but it's not here. It's in the TP, in the preferences. You can come to the grids and change the grid. So the color of grids is now something like this. It's color 18. You can, let's say, make it more visible, make it color 20. And once you press apply, and you see they're obviously more visible. But it's kind of irritating when the color is very sharp. So let's put it back to the original color, which was 18, and it's much better. So as you see, we have such a fine grid here. It's 1 millimeter. So we make it 12.45. Here also 12.45. And it's the standard one that we have. If you go to the PCB editor, we have the same thing here. But here, if you press G, you see that you have different steps. And in the grid properties also, you can change it. Step X and also step Y. Not to mentioning all. So if I bring my components here in this black area, which is your PCB, and you can change it as you want, but by changing the grid here, if it's 1 mil, then the movement of my components are very fine, because it's 1 mil is quite small. But if I change it to, let's say, 10 mil, then you see the dots, the stance between the dots become bigger, and the movement is larger. And if I here, press G again and make it 2.5, almost the same as we had, it becomes like in the schematic editor almost. So how free you can move your components depends on your project and your needs. But usually it's good to have the ability to move your components more, so that they can come very close to each other. So it's also good that you can also make difference in how you can move your components, and it's by pressing Ctrl R. If you press Ctrl R, the original setting, without pressing, it's like you can move the components and they can cross each other. But if you press another one, then the second one, it doesn't allow you to go closer than a specific distance, which you can, I think, set in the design rules most probably. And if you press R again, Control R, then it will move the components. So these are the options that you have. So back into the grid subject, if you press GG, then you can set your grid here, because as you see in this menu, you don't have all the steps that you want. So I want to make this 100 mil, which is 2.45 millimeters. And now I have exactly these steps as in the schematic editor. So when you want to control very small distances, then you need to set a finer grid, but when you don't need, you can make it bigger. In our case, we don't need such a small and fine grid. Now it's a good idea that we start with the PCB editor. They're very similar, but in the file you also have the import and export of different things. And two important parts in the file, FF with the shortcut FF and FB, the fabrication outputs and assembly outputs. And these two outputs give you very important ones. Actually, if you want to send your PCB for a manufacturer, you need to give him one of these fabrication files like Gerber X2 files or Gerber files or ODB++ files, depending on, most of the manufacturers use Gerber X2 files. Some of them also accept Altium files or Eagle files. You just send them and they say, okay, we accept Altium. And once you upload it on the website, you'll see. I will show it in another video, but here we're just explaining. And also the assembly output, like the assembly drawings that you have and the pick and place files for manufacturing. Another thing that we have here is the prints and default prints, and this default print gives you the ability to do different kind of printing, but one that you can use very much is the PCB prints that allows you to do a scaled, the same size print of your PCB. It's a good idea. Later I'll post a video to show you how, but whenever you make a PCB, it's always a good idea that you first order the components, and once your PCB routing is over, you check the components with the real size print of your PCB and see, all the components are okay, they fit on the PCB, and then once you're sure, you send it to manufacturing. Because if you don't do, it usually happens to the newcomers or the people who are new into PCB design, that they make faulty footprints, and once the PCB is there, they see, oh my goodness, I cannot print it, I have to throw away this PCB. So this will help us a lot. Back in the PCB editor, I want to change the size of my board. It's obviously pretty big and I don't need such a big board for such a small circuit. So if I come to view, I have three main views in PCB editor, and the first one is the board planning view. The second one is what we're now in, and a 3D view if I press. So by pressing 1, 2, 3, you come into those different views. And by pressing shift, this is one of the nice features of Altium, that you have a very powerful 3D viewer, and you can have a 3D view of your PCB components and also the layers. It's just a 2-layer, but you can zoom in and exactly see what's going on. This is very nice actually and useful in practice. So sometimes it might happen to you that all of a sudden you lose your PCB and you come here. Say, oh my god, where is it? So it's not a problem. You just press VF and you go back to where your PCB is. It might happen, so it's good to know. We have VD and VF. VF will limit you to the size of the PCB, but VD will limit you to the size of your components or your room. As you see, if I press VF, it comes to the whole PCB. If I press V plus D, it comes to the components. So if you want to make the board smaller, there are different ways, and I will explain them in the part of geometry. But now let's plan a board, and once we're in the board planning mode, in the design menu, we can edit the board shape, and very easily we can change this and make it smaller. Again, if I change my grid, I will be able to move in a finer way, as you see here. So I make it 1, and I come here. I believe this is pretty big for such a PCB, so I go back to the 2D view. I delete the room because I don't need it, and I want to see what we have here. So we have the power supply, and this is the power pin, and I want to move them. So moving them is the same by clicking and dragging, and you can also move the names or the designators, and I bring the other. Again, with space you can rotate them. This is the input, I think, and this is one of them is the output. We can check it in the schematic. The output is actually there was something wrong here. So I press CC DU. I think we made this mistake later after we imported everything. Okay. Sometimes you have many files open and you need to save them all. So you just press FL and they all will be saved. Here we have this. So P2 is the output and P3 is the input. Okay. And as you see, this is actually not very big, but the footprints are very big. So I select all of them. One way of doing this by doing right click and find similar objects, and in the menu that shows up you press same text and then you press apply, but this select match should be here ticked. I think it's normally not, so you then press apply and they're all selected, and another menu will show up, and in this one you can just change them. And this is what we usually do. We make them from stroke to true type because they become smaller, and to be more visible we make them bold, as we do here. So now they're much better and we have more space. So the biggest, I think, size that we can make for our board is like this. And considering everything, I'm just evaluating how much space I need for everything. And as you see, because the control R is there, so I put it in a way that they move each other. So I believe half of display, something like what we have here, from right to left, it selects them easily. So let's say if I go back to 1 and press D again, then I can define it also and make it small as this. So if I go to the PCB Editor 2D view and press 3D view, I see that my board is already very small. This is also the case when you go so far away and you don't see your PCB in the 3D view, you press VF and it comes close. Okay, now it's time for placement. Of course, this is a very simple one. You can place it as you want, but this is a general rule, and I will state it, I think, many times again. They say that 90% in PCB design is placement. So if you place your components in the right way, later it will be much easier for you to actually route them. So if you do a right placement, so if you place your components in the bad order, most probably you'll end up having a bad routing, and in many cases it will ruin your day and ruin your PCB design, and you might even fail PCB testing of EMC and things like this. As a result, always try to have the best placement. It takes some time. You need to place your components wisely, and there are many factors like thermal factors, electrical factors, EMC factors, signal integrity factors. We need to consider them all into account. But here now we just want to learn how to use the software. So for now we want to do the placement. Okay, we go back to the schematic because we see it very clearly here, but in the PCB we don't know what is what. We start from the input connectors and we put the connectors in the right place. So I press this one and then it will be marked here. You see, I see, so this is the capacitor that I need. So I put it as close as possible to the place where it needs to be, like here. So I put it here. And I don't care about our components. You can just move them somewhere else. We just wanted to define the size. Usually the size of your PCB is defined by other factors like your box or the space requirements that you have in your project and the cabinet or whatever the PCB is installed. But here there's no such thing. It's just a tutorial and we are placing them. Let's say it's better to have here. Okay, and the next one is our transistor. If we select multiple components, no, I want to deselect it like this, then they will all be here. So one way of finding them one by one is by pressing T, O, and C, which is like component placement from tools, and arrange. C means reposition or replace the component. So I now have the first one that I selected, and it's the transistor. Then I have this resistor. Then I have this one. I have the other one. And you see I turned them with space. And another one here. Let's say I put it here. Okay, so now we have all of them here. If I want to align the components, I just press A, which is for alignment, and align right, or A, R, that will be in the same alignment. If I want to have them make them have the same distance, again, align, distribute, vertically, and they will be distributed with the same distance. Always try to place the designators in a way that you will see them once you have soldered the component. So do not place it, for example, if I can place it by pressing Ctrl and Shift, you can place it inside. I don't place it here, for example, because I won't be able to see it later. And try to place every designator next to its component. So see, this is for R7, this is for R8, this is for R3, and this one is for R4. I don't put R4 here, because then when you want to solder, you make a mistake. And you don't see them. C3, okay. Now we go to the next part. This is another cap. And the transistor, I select them together. TOC. Okay. I put it here. Then the transistor. So we see that the output, which is P2, is better to be placed here on the above, because if I move this here and I replace these two, it will be better. Align right, and Control Shift V will also distribute them. This is what we do with align and finding this. Control Shift V. As you see, this it will distribute them vertically. Okay, now we have the Q2, we have the Q1. In big circuits, you can turn off all of these designators, do your placement, and then looking for what you actually need to do about it. But in many PCBs, it's not like small ones like this. You don't need to do this, and you just move them easily and quickly. So let's go to this resistors. We have R1, R5, R2, and R6. TOC. And this one, which I believe is better to be here. Again, align right, AR, Control Shift V will distribute them equally. And this is R2, R1, R5, and R6. And we have this also for the output. So we move these components a little up. It's this one here in between. It's a good start because we have SMD and through hole components at the same time. So I bring it here. in front of the connector. In this case it's not very important, and we still see that we have space, so we save space. We don't need a lot of space in this case. So if I move this a little here again, and also move the components up again, we have distance, because at the end this transistor has a height, and you first solder these assembly components. In reality this is not a problem. Now we can also distribute them equally like this to make the board even more beautiful, and we still can make the PCB smaller. So we come to the editor here and we do the design and edit board shape. So I still can make it smaller. It's always a good idea to do so when you can, because smaller PCB is cheaper. Of course not all the time, but in most cases. This is very important in PCB design. It's not just a matter of placing components and just connecting them. It's electronic design, and in electronics you need to know what exactly you're doing. If you're placing a resistor, if you're placing a capacitor, you exactly need to know for what you're doing this. So I also align these ones, and here we go. We have all the components here, and we can start routing. So let's do it in the next video.